Good afternoon. Thanks for obviously inviting me to come here. It was a nice kind of trip away from London. I'm essentially presenting the framework, I guess, for today's speech. Is really to talk about how, as DMA, we kind of, or BIM has helped us, for example, as architects in ourselves internally, how we collaborate with the design team and how that's helped for example, and also with the client stakeholders. And what I've done is to, at the end of each session, put a little case study, which hopefully kind of gives you a flavor of some of the smaller projects we worked on. But in between that, there are other projects which are kind of larger, so it shows the potential and the way that we've grown from a small practice sort of into a slightly bigger, smaller practice, I guess. I've been at DMA for 6 years, and we've grown from 4 to 14 people in the last sort of 6 years. And so I've had direct sort of visualization of when we first bought BIM, or Revit, I guess, in that sense, about 6 years ago, to the whole office now using it within all the projects, in fact. So I'm going to just start. If we go in, obviously we kind of use it as a tool for designing and delivering our projects, and like I said, I'll go to the first session, which is obviously this one here. Now, I think general understanding is that we know it's not just a 3D modeling tool with information. It can incorporate other things like time, the cost, and also now the whole talk about FM and full life cycle, so kind of possibilities, and that's obviously driving the kind of the government's mandate forward. We kind of came into Revit. I won't talk about BIM necessarily, but into Revit software, because we were initially modeling things in 3D, Rhino, and then actually producing the construction drawings, for example, in 2D. There's a huge lack of sort of coordination between the two and a loss of time and data. And led to obviously inaccuracies during that processes. And really, David and Fiona, and the two directors, sort of looked for solutions to kind of combine that in one sort of piece of software, really. And hence, obviously, where we came into buying Revit and also getting involved in the building information model. And we also wanted to use a tool which can enable us to go from inception to completion. So it's not having to jump from different softwares or different ways of working, but being able to kind of input more and more information from the beginning to enrich the model or the kind of database, and to deliver it in one software package if possible. And obviously we got now the BIM overlay with the Reba, so there's clearly changes to the way that the original Reba stages is, and that's obviously been done in order to kind of push the agenda or to meet the government agenda to get everyone up to level 2 by 2016. So I mean, obviously, there's other documentation of that, which I'm sure some of you have seen, for example. If you go into the idea of if you first start with architect, for example, this is really about how, for example, we interface with the tools, and I guess the kind of efficiencies that is driven within the practice, as I guess people know as lonely BIM, where we're just working internally. So I'll run through a series of slides which show the different ways that we use it to design, to develop projects, and to deliver. So to give you a bit of flavor. So from the very beginning, we use the BIM, or when the project is conceived, we're already in the kind of BIM environment in the sense that we put information. So these are quite early sort of three-dimensional massing studies that we did. But obviously the key thing there is that you're able to output volumes, areas, and also you can attach cost data to that if you're working with a client over a number of periods and they're happy to obviously give you that information. So very early on working within cost constraints as well, rather than just sort of physical constraints. But obviously we still use kind of sketching, depending on obviously who the client is, who the audience is that you're trying to communicate your ideas, whether it be internally or externally. So, we're able to use some of the massing to overdraw, for example, or annotate and send. So I think we had to be careful that it's not, using the Revit tool, for example, isn't the only way to kind of communicate. We can use it to also help or aid us to present to different stakeholders. But obviously, there's been increase in the kind of information you can get. So rather than buying OS maps, we're able to now kind of get three-dimensional maps or models of the area. Fairly cost-effective, but accurate to 40 centimeters, which for early sort of pre-application kind of stage is very useful, and also allows us to understand the site not just in a 2D plane, but in a 3D. Which obviously benefits in terms of understanding things like rights of light, daylight, kind of shadowing, overlooking, etc. So we're able to really prepare very quickly large massing, or massing in kind of slightly complex sites, but we know we can give that information to the client. And as early sort of commercial clients or even public sector, which this is, we're able to give them areas and number of units that might be able to get onto that. So it really allows them to kind of make very quick decisions without necessarily spending a lot of time from our side. So the whole workflow process is speeded up. And obviously with relative software like Ecotech, which comes like in a bundle, I guess, when we bought the software, we're able to do, again, very early sort of analysis of daylight sunlight. This is not saying that it's going to take over the daylight sunlight consultant, but it allows you to make big decisions, which obviously will have an impact further down the line. And using Revit internally, you've got the Green Building Studio, again, the ability to kind of test, for example, using the kind of the uploading facility that you have, to look at things like energy kind of consumption in the building, for example. Again, these are probably 10, 15% plus or minus. So we know they're not going to be, they're not going to kind of reduce or increase kind of the kind of efficiencies in the minute scale. But it can, obviously, things like orientation, big decisions like that can be done and tested very quickly, and then can be validated later with the specialist consultants. I guess the biggest change is the way that we work within the office. So as everyone goes into the office, they open up the project, whether we're in the conceptual stage or early feasibility, or at this, for example, in this, which is a school in central London, about kind of detail stage. Everyone is actually engaged with the three-dimensional school, the kind of areas, right from the beginning. And that's a huge change in the way that we've been working. Normally, we've obviously been working in the 2D plane. And what it does is, it allows us to kind of spot, just because of the understanding, the better understanding of the spaces, any kind of errors that might be, to kind of eliminate those very early on. With having sort of multiple people being able to work on the same project or the model, or the database, I should say, we're able to kind of almost peer test or peer review them without necessarily having to go through a checking process. So that's one of the biggest changes here, and very quickly you can see the intuitive nature of the software itself. And that's, I think, true for all different types of software, not just the Revit platform that we use. And this is really just another view into that database. So this is obviously looking in a more traditional 2D sense, where we're able to add different data as we go through the process, for example. We know that any change in one place is a change in all of the places, whether it be in the plans or the three-dimensional views, the sections, but also in the schedules, for example. So here we're just going through the various call-outs, which obviously generate elements of details or sections or elevations. So it's very powerful, and again, I think comes back to the efficient ability to kind of produce a lot of work, and it's going to be coordinated. You're not having to double check. You're not having to sort of do a 2-3 point check in that sense. And I guess from that, you can output things like the plans, the elevations, sections, and details, as you can see here. And I think the key thing is all within the same platform, which is what we were striving for when we bought it sort of 6 years ago. I guess depending on what stage you're in, you can add obviously certain data. So for example, in this one, you may not know how the build-up of the wall is, but you can assign various performance criteria. So it's a performance-based model or level of information. You can then move on to construction, where you know what the wall type is, so you're giving it a prescriptive kind of level of detail. And all the tags, for example, in this kind of view, are intelligent. So the wall knows that it's meant to be 40 dB and 30 minute fire rating. So again, that as long, as you're modeling, you know that the tags are going to be accurate. It's not like having to check it again, increasing efficiency and accuracy. Detailing would work in two different ways. You can model a certain level of detail, but obviously you do overdraft in 2D because it just doesn't make sense to model every screw, nut, and bolt. It would make the model too heavy and it's unnecessary for different deliverables. And one of the key changes is obviously things like packages that we're sending out to clients, or to contractors. By putting, for example, a three-dimensional view, it helps to kind of really get across what we're trying to do in that particular space or in that particular package. So again, reduces the kind of ambiguity or mistakes or misinterpretations within the team all the way down to the contractor, subcontractor level. And I guess this is just a slide to show the kind of power of the process. These are all 4 schools with the same contractor client. They're all in tight sort of London urban sites, but they're all composed of really essentially the same building blocks, the walls and the doors, the floor build-ups, all of them are fairly standard because that's the way that we've understood to work with the contractor client. So even though they look very different, they're actually made up of the same components. And that's allowed us to really enrich from one school to another our database and our knowledge of the schools, but also the way that they construct. And obviously you can blow that apart and then bring that together in a new project, which is what we did in this scheme, which is for the local authority, Westminster, where we had around about 8 months from essentially starting from being appointed to completion to kind of essentially refurbish and remodel sort of 3 or 4 stories of their second largest asset in London. So that could only be done because we had all that data from before and we're able to blow that and put that back in. We could spend more time on actually working on the complex interfaces rather than the layouts and so on and so forth. And sort of the end products. Case study 1, sort of going back into a smaller scheme that we just did. It's a private residential kitchen living extension and some internal modeling, quite typical of, I would say, what people think architects do, or smaller practice, for example. Existing building. What was interesting was the architect previous to who got planning already had a model, but the client wanted to make some certain changes. So we were able to, I mean, this is just changing the material here, for example, but we were able to communicate that very quickly to him and to get sign-off, also taking different cuts, for example. What we found is that we're able to make changes which inevitably are requested, but they weren't taking us a new set of drawings or kind of produce. We could just change in the model, agree all those before actually producing the construction drawings or detailed drawings, which essentially what it is. And working with a competent contractor, actually the level of information we need to give to him was actually a lot less. And again, I think it took like 3 or 4 months to go from post-planning to completion in sort of some of the construction photographs. Design team, again, so this is where we're kind of collaborating with, we've been lucky enough to work with contractors, some of the consultants like structural engineers who've been willing to kind of push the BIM agenda themselves internally. So we've been able to have collaboration. I think this is one of the biggest changes again. Culturally, we're now focusing on the model, a virtual prototype of the scheme itself. So in our office, we've got a projector, much like this, and everyone's sitting around the model and discussing that. So if there are any queries at DTM, for example, we're able to resolve it rather than it just being another action or a note in a huge Excel spreadsheet, for example. So it's allowing everyone to kind of collaboratively kind of resolve things in the meetings as opposed to just another action that goes taken away. And as a result of that, there's no sense of, oh, you did it wrong, your model's wrong. It's actually just said, okay, fine, we need to resolve it. Let's just get on with it and move forward. So that's been very different. We're able to obviously aggregate different models. So in this scheme, which is the largest one we have in the office, we've got the structural model, the M&E in certain areas, and the architectural. We would bring that, for example, say a couple of days before the DTMs, do various analysis, clash detection, etc., and then bring those things up at the DTM. So you aggregate everyone's individual models into one combined one. There are other softwares like Navisworks, which obviously are appended. You append the model in this software to run, for example, clash detection. The principle, obviously, is that you can't, the two things can't occupy the same space, and hence, obviously, it automatically knows where those clashes are. But also, you can put tolerances. So, for example, if a piece of kit needs a certain tolerance for maintenance operations, that can be put into the model as well. So, again, from this, you can output a report, like a HTML file, which basically means that becomes the notes and actions for the next DTM. So, again, you're working in the same model, and if once the model changes, you bring that in or append it or link it. So you're not having to remodel anything for just one specific exercise. And so again, we're able to bring, this is for example, a Tekla model from a steel manufacturer we brought in for the education project that I showed you earlier, and integrating that with the architectural. So it's really about being able to bring different models from different manufacturers who have their specialisms as well. We're also, as I mentioned before, able to put in time into the models. So for example, if a contractor has a construction program, they can use that to visualize how they might kind of resolve health and safety issues, phasing, sequencing. But also, for example, in this scheme which we did, we were asked to animate it for presentation to planners to kind of try and reinforce and kind kind of alleviate their worries about the impact on the local kind of road system, for example. So there's a little animation that we were asked to do. And that was for a contractor, logistics contractor, who was looking to essentially win the project. So again, that ability to put time in allows you to visualize. And that doesn't necessarily have to be at this level. It could be just in the massing level at early stages, working on a master plan, or even in a smaller development. Mentioned cost. We've done a couple of exercises with various cost consultants. What we found is about 50% accuracy, and that's due to really the fact that the way that the QSs are measuring things is very different to the way that the software is measuring it. Software would measure exactly how much plasterboard is in that wall, for example. The QSs might just measure the whole wall. So what we found out, all the tabs in yellow, for example, are things where we had to understand how other consultants and practices actually measure things or use the model. It comes back to this idea of the BIM execution plan, which you may have heard of, where you really kind of set down at different stages, so the different 7 work Reba stages, what level of detail the model is, who's providing that, what it's going to be used for. Previously, we had done a lot of details in the models, which were completely unnecessary, because they weren't going to be used or information wasn't going to be extracted for those purposes. So that's, I think, one of the key things to take away is really understanding, and I think goes into the FM part as well, how does the client and the end user want to use the building or the operated or the model, so that we can input that level of information at the right stages, so that we're not kind of spending more time than is necessary. Here, for example, is a refurbishment that we did for some area service for the local authority as well. The M&E was actually all designed by the contractor, so they had that information already. We could append that to our as built model and hand that over to the client, so they could, for example, run their facilities management and look for where the filters might need to be changed, for example. So there are already subcontractors who got the models, but they might not necessarily be asked to it. So that kind of ability has sort of been lost. Case study 2 is for public sector housing in Westminster again. This is a listed building or estate, and we've been asked to fill in the lower kind of undercroft with 2 flats, obviously trying to maximize housing in the borough with larger units. So again, very different to the previous case study, but the complicated thing here was really to do with the levels, for example. There's a ramp in between from one end to the other. And so by modeling it, we were able to kind of understand this geometry, which wasn't necessarily understood at the planning stage. So for example, in the model, I was able to highlight what's existing in the pink, the blue for the external, the yellow for the internal. So easily kind of color coordinate that and communicate that with the rest of the structural team and the M&E team and the client themselves to explain, look, there are these issues that we need to somehow resolve. And so I was able to use that, the modeling of that element. No need to necessarily model the rest of the building, because that's not really in our scope. And then to kind of finalize on a complete build and obviously visually kind of represent that kind of in a simple way. But obviously still be able to output the kind of standard drawings that many people require in terms of the levels, etc. So I think the key thing here is that there's a kind of a simple solution or problem, but using 3-dimensional. If I wasn't using 3D, I wouldn't be able to kind of resolve the geometry, but using the same model, I'm able to output the drawings which will go out for tender. So I'm not remodeling, I'm not wasting resources or any of the fees, for example. And finally, the third sector, the client and stakeholder. I think it's obvious that there's certain clients who obviously engage with different types of presentations, depending on who they might be. We had to present this to some of the residents in the tower block, where they were having their ground floor changed. So we kind of constructed the model of the existing layouts and overdrew it, because we knew from previous experience that they were kind of more engaged, or they could engage with this much better. Really about kind of client management, so they don't sort of misunderstand something. Again, this is the school that I was showing you before. We're able to go and speak to each of the teachers or the heads of department, show them where all the furniture was. So again, they could make comments about layouts. And if they wanted to move something, we could just do it in the model on the DTM or the design meeting that self. We can also use that for things like looking at color coding, so we could put certain colors on the walls. So again, you're able to make real-time changes on the model, not have to sort of write it, note it, and then take it back and then change it back in the office. So it's really about client management or managing clients' expectations and getting sign-off. Again, we can use append the model to, again, this is the case, Navisworks, for example, to run a simple fly-through. Same model, not a new model, and it's not there to be kind of sold for marketing, but it's really to kind of just to make sure that the design team understands it, the client understands what he's going to get, and for us to also to kind of validate that the design actually does work. You know, we might be able to see in 3D some parapets don't work, for example, or windows are in the wrong place. So, but then we can also use things like 3D Max to kind of do renderings, which may be useful for planning or kind of marketing reasons, which is sort of what we did in this scheme. New build hotel, where we gave the model to the visualizations specialist, and that reduced the time because they weren't having to model the building again. And that's probably saved about a week and a half in the process, and obviously saved money for the client. And they were also then able to output these visuals from that. And again, they could just flip the model and then redo the render for a night time. And then really just going to the final case study, we've been working with sort of job A4E, who kind of do job C kind of elements of things. Office fit outs, we've done probably about 18 of these to date. Very simple process, go there, survey the site, do some space planning, and then essentially produce a construction set of drawings, or 1 or 2 drawings, and that's given to the contractor. This is, for example, typically what we're given with in terms of the site. We would do the space planning, produce, for example, a visualization which can be given to the client for sign-off and with their team. And the key thing there is that all of these tables are from their standard specification. The client has a standard specification of finishes, wall types, furniture. So every project, we're able to just use the same ones. And obviously, we can probably go from surveying to doing the space planning in a couple of days now. And then we would output in 1 or 2 drawings with all the kind of comments and notes, the construction drawings which are taken by the contractor and constructed. So that process could be as little as 4 days, essentially. And that's obviously well within our fee proposals, going to get the end product. So I guess in summary, there's obviously these advantages. Hopefully you've sort of seen some of them. So verifying the design through the kind of simple contextual analysis. Working from one database, the idea that any change in one place is change everywhere. And you can obviously append that to lots of different softwares or to kind of get different presentations or different information. Obviously cost avoidance through early detection of possible clashes, things that might not work. And obviously the efficiency in the production of the information. So I guess one of the things there is when I first started in the 60s, our biggest project was about £2 million. We're now sort of doing £35 million. We've probably done, the schools have been in the range of sort of 5 to 10 million, and obviously we're kind of getting repeat business because the quality of the information is getting better. There are obviously challenges, cost, how much does it cost to actually implement or kind of get the software, the hardware, large file sizes and training and expertise. I mean, I guess we've done a bit of a calculation, so this is what we feel is you need to sort of buy or to get in-house. So we've got obviously days for training. We normally have like a 5-day sort of boot camp, which we had at the beginning. Now what we're finding is that as we normally take, say, diploma students, for example, as they're coming in, we're able to get them trained by internal staff as opposed to necessarily having to get a specialist trainer in, because everyone's, all of 12 of our staff members, architects, they're all using the software. So then obviously you've got this license for the product itself. Then you have like the hardware in terms of the kind of fast computers, and also the network cables. We think we calculate around about £10,000 per person per year, essentially. But what we were asked to then sort of map this out at the beginning, sort of from 2007 to now. The kind of cost of the cumulative cost of the construction projects is now definitely kind of veering up away from the kind of overheads, essentially, and the training. So we've seen a marked difference in the amount of money we were spending originally in relationship to the cost of the construction of the projects, and now the cost of the construction project is definitely going up. So we took a gamble, I guess, an educated gamble, and it's sort of definitely paying back for us, I guess. Then questions obviously later on, but that's it. Thank you.
small company in Swindon. We do, it's only six of us, plus an accountant. And so this is our brief history of encountered Revit. Yeah, a fantastic bit of CGI there that was done. First saw Revit demonstrated to me in 2001, and I thought it was a very interesting product. Then obviously in 2002, I think it was, Autodesk bought it, made it very interesting, just kept an eye on it. And then in 2005, we decided to deploy the Revit 8 into the practice. I mean, so we'd given it to Bill to trial out for 2 weeks, and he just said, oh, brilliant, got to get this, things like that. So we did. And now in 2011, we fully adopted it right across the office, and we don't use anything else. We only use the AutoCAD and our ArchiCAD for legacy work now. So all our projects now are done in Revit. So that's a brief history. And what I'm going to do now is hand over to Bill to talk about one of our major projects.
Thank you. This is Ferrari Maserati in Swindon. It's been dubbed one of the biggest and greatest Ferrari dealerships in the world, or at least North Europe, by the Ferrari bods that came over and opened it, which is a huge accolade for us. But this all started back in 2005, and if we could just, slight technical glitch here, hopefully it's going to run to plan. In true fashion, the client came to us in 2005 and didn't make any real decisions about sites and everything. And I think it was about 2010, then bought this site and said, go, go, go. We've got about a year and a half to get this done, having no designs or anything. So it was a very fast-track process. We were on site digging foundations, having only tendered the foundations and steelwork and cladding, so all the rest had to be done whilst they were digging. Whilst they were building, there was a complete catch-up with all the design production information, all the tendering, all the cost planning, everything. So there was a real need to speed this up. The other downside to this particular position was that we were in the middle of the recession. There was many redundancies at our practice, and there was left with the 6 of us that there are now. When this came on our doorstep, we also now had an influx of housing work, and so it was left to me to do the whole lot in a rush, in a program that we hadn't used for commercial projects before, obviously used for many years previously. So this is just the time lapse of the 52 weeks we were on site. It's roughly about 5,000 square metres of dedicated dealership for Ferrari Maserati. Space for about 50 cars, if they're spaced nicely. You probably get about 150 if you pack them in. There's 23 workshop bays. It's about a £6 million building, contract sum. And at the outset, we took the approach that it was going to be a lonely BIM situation. For those of you who don't know what lonely BIM is, it's basically, it's me on my own producing information that is useful to me. I've got no outside consultants plugging information in. So if we can just switch back a second. So hopefully that gives you a... There we go. So just moving on, the interesting features. So this project, there's down the bottom here, there was things that this helped me out with using this software was that there was 2 pylons straddling the site and the high voltage cables in between. Now, when we consulted the electricity board, they gave us typical CAD drawings of chainage distances and some blowout distances of the cables, because apparently due to temperature, whether it's snowing, time of year, the cables sag, they can move all over the place, they blow in the wind, and so it's not just a case of worrying about the cables that are there on site. So rather than try and work out, do a design, work out whether it's going to fit into this, get the electricity board's approval, we actually chose to model this boat, which obviously represents the blowout distances and everything of these cables. So real time, whilst I'm sat there with the client, fiddling about with what was started as 3 boxes, we can clearly see whether this is actually going to work physically on site and whether we have to rein the client in and tell him he actually can't use that 1 acre of land that's underneath these cables cost effectively. Just some other, not necessarily interesting points about the lighting, but there was a lot of, Ferrari specified that you had to use a lot of these lighting details, which from the ground look great. Above the ceiling, there's all sorts of undulations and voids and everything to create these light boxes. Now, typically M&E would come along and just throw their cables and throw their pipes anywhere they wanted, which would obviously cause clashes long term. What we were able to do is give the 3D model that we created to the M&E boys, not with any view of getting anything back from them, but so that they could sit there and they could model their M&E stuff. Now, we went through the whole project and there was one clash between what I was trying to put in there and what the M&E boys were trying to put in there, which from their perspective, they were over the moon with. Other interesting features that this product helped with was the architecture that Ferrari weren't happy with at the outset. They are very strict in what you are and aren't allowed to do. We wanted to go with a more exposed structure in the workshop, mainly for cost reasons, to be honest, so that we didn't have to plasterboard the walls. It's not as cost effective to do that on such a large space with the budget that we had. So you're able to quickly, without any more modelling that needed to be done to produce the drawings, you can show Ferrari, you can show the client, you can say this is roughly what it's going to look like, or exactly what it's going to look like, without taking any additional time to do this, so that in the end, they at least know what they're going to be getting. That was a huge leap forward for us because there's almost no deliberation, no request for further information, because you're giving them the representation of what it's going to look like. So they're very quick to sign up to something, or very quick to deny you something if they don't like it, obviously. The BIM approach on this project, as I said, when we started at the outset, it was new on a big commercial project to use this software. I was fresh out of university. This was thrown at me by my boss and said, run with it. So quickly had to model, as I say, this started out as just 3 solid blocks massing on the site, just to give a rough representation of how it's going to sit in relation to roads, in relation to views and things. And as time progresses, you just keep adding more and more detail when you get the information. So glazing goes in, the signage goes on, cars go in. But primarily the BIM approach was that I'm going to be doing this as a lonely BIM, but it's still going to give me the benefits over doing it in the traditional 2D sense. As I say, started as lonely BIM, but very quickly people got wind of what was going on and were very keen to utilise the information that was being produced. So as I said, the model got handed to the M&E boys, who inserted all their information. Now again, with the exposed steelwork and the exposed spaces in the workshop, and there's a used car showroom upstairs, which is also very exposed, it gives them feeding back to me, not just from 2D drawings or plans. I can clearly see where events are going to go, where the plant's going to sit, or what height things are going to go at in terms of running around the walls, which I wasn't happy with. So it's very quick for me then to go back to them and say, not happy with this, that, and the other, rather than waiting for it to get on site, them to build it, and then have an argument on site because information hasn't been portrayed in the correct way. Again, although it's BIM, although you're producing 3D information, there is absolutely no need whatsoever to be farming that information out to whoever's going to be reading the drawings. Typically, it's going to be, for instance, a brickie on site is not going to be interested whether he sees a 3D representation of this information or whether he sees the traditional 2D plans. So don't feel that just because you're producing the 3D information, you have to display that and convey that to others. You can just stick with the 2D plans. And there is still a benefit to that, which I won't go into the nitty-gritty, but just drawing walls, drawing elements, it's drawing one line and it produces the information for you. Rather than in AutoCAD, you would have to, the construction, then the plaster, then the 2 layers of plaster, and then you've got to do it on the elevations, plan sections, as we've already heard in the previous presentation. So just trying to rattle through this rather quickly as we've got another one to go through after this. But the lessons learned, mainly the first one is continually assess your end goals. You've got to, when you start these projects, you've got to know, I think we heard a little bit in the previous presentation, but you've got to know what you're going to be doing with this information. If it's just for you in the lowly BIM situation, figure out what you're going to be doing, what sort of drawings you're going to be producing, how big the project is. Does that desk need to be done in 3D? Can we just stick with the 2D representation on plan? Because everything three-dimensionally adds to the overheads of the machine, and then working becomes slower. So there's a real need to continually, throughout the project, work out what you need to do with it and how you need to get that out at the other end. You can just about see this, but the visual there, I'm sure everybody's come across this, exploded dimension strings in AutoCAD, or where they've changed the number but haven't actually changed the information. So immediately, that information can't be trusted because it's wrong, essentially. Long gone are the days where we're scaling off drawings and the note in the top right-hand corner that says you work to figure dimensions only is still viable. We're farming out digital information and we're expecting it to be trusted by the others who are looking at this digital information. So if we start doing things like this, same, going back to the age-old quote of rubbish in, rubbish out. Revit and or other systems that require BIM, you can't do that anymore. It's got to be accurate and it's got to be on the money. If you work, you can work loosely at the beginning, but essentially when you start collaborating and when you start producing the information, if you don't do it right, you're going to come into problems. I could give you an example of a guy at our office who we've just about got signed up to this, but again, the idea of BIM and the idea of this process is that you can take it from cradle to grave. You can start at a planning drawing, at the concept model, and you can end up at the end with a working drawing having done no redrawing whatsoever. We found in the office that because somebody wasn't prepared to work reasonably accurately at planning level, we were having to completely redraw his models when we got to working drawing levels. So again, it was pointless going down that route. You may as well have isolated him and started from scratch when you got to working drawing stages. So it's a real sort of culture shift to try and get people working like this. The other lessons learned is trust your information, but again, going back to your accuracy. If you can make sure that your accuracy is spot on and you can make sure that the people working on the project have the same ethos, you really can trust the information that is in front of you, whether you believe what you see or not. But because you're working in a model, as we saw in the previous presentation, you can cut sections wherever you like, you can cut plans, you can do sort of call-outs, you can do little assembly models if you want. So as long as you're modeling everything correctly or you're drawing the information correctly, if a contractor phones you up and says, can I have a section here? Within a couple of hours, you can have the section done and farmed out to him without going, it's going to be a couple of weeks and delays on site, for example. So it's really a case of trusting the information that you see and that you're getting out in terms of schedules. Again, just 3 steps about what to do. It's a bit stark statement, but forget everything you know about 2D drawing. It's not 2D drawing. The top workflow is traditionally how we've worked in the past, where you start with the feasibility, you sort of throw that in the bin and you start your planning drawings. And then when you've done those, you sort of throw those in the bin and you start your production information drawings, all in different drawings. And eventually those drawings will be finished and built, and then you'll farm those off to the sales guys who will then produce their 3D models or their visualizations. The BIM workflow is that you're doing all of those things concurrently. We, as you saw with the visuals on this presentation and the next and the previous, you can produce the 3D renders directly out of Revit with a bit of touching up in Photoshop, right back at the beginning, the concept stage. So you don't have to go to the extra expense of paying somebody to produce your 3D visualizations anymore. You can do it at a click of a button. The production information begins at day one when you're starting the concept. You're putting walls in. You may not know what those walls are going to be, but you can guess. And if, as the time progresses and you find out that's a blockwork wall rather than stud, you change it. And it's as simple as a click of a button. Now, I'm going to be slightly contradictory here, so I apologize for that. But this statement is provide as much information as possible. I hadn't envisaged that any of this information was going to go out and be formed as 3D information or used as 3D information by anybody else. But it's useful to me as an architect so that when design decisions have to be made, I can do little call-outs, I can do 3D views from inside the building, and again, going back to the accuracy and knowing that what is in there is right, I can look at that view, I can take that section and find out what's going on in there and make informed decisions about what's on site. So that quick decisions can be made when they're needed to be, and again, this is a perfect case study for this. But I'm also going to go on to, on the next slide, but the complete opposite of that previous statement. So I apologise for that. But the other thing to do is to manage your drawing files and the people working on your drawings. If the people working on your drawings don't know what they're doing, chances are that they could mess it up quite quickly and quite easily. Similarly, the drawing files, again, if you put too much 3D information in, the drawing files get huge, you can't actually use them in any sensible way. There's also going into the collaboration across, I know this is aimed at smaller companies, but they can also work on different sites, either in the country or around the world. So it's again managing those files that you use with whatever system. We use Revit in the office, and that allows for many people working on the same file at the same time. So it speeds up the process. If you need to get a drawing out quickly, you can do that. So it's just managing those files, managing the people, and how you operate within that is a key process to go through. Again, this is a slightly contradictory thing, but overcomplicate the model. I've touched on it before. This is an example that we did many, many, many years ago when we were just sort of playing about with it. 2006. And every single brick there is modelled as a single entity, which is not how you do it. Please don't ever do that. This was just literally for this one window, and this one model nearly broke the machines because it couldn't handle it. Keep it simple is the age-old statement, and if it doesn't need to be every single brick, don't do it. It's not what Revit was designed to do, or other systems. And there's much simpler ways of doing it. And similarly, if you don't need to show that 3D information to whoever needs it, don't show it. There's no point. So keep everything as simple as you can. Similarly, if you do want to show the 3D view, go for it. It's there. You know, you can use it. So, which goes on to the overcomplicated drawing issue. Traditional 2D drawings are still fine just because you're drawing in 3D, so don't go overboard for the sake of it. Biggest thing with BIM is, and when you're collaborating, this was a Motorrad dealership that I did at the same time as Ferrari, and this one we actually used the contractor's steelwork model and put it into our model, and I'm doing the same thing on Porsche at the minute, and I'm tearing my hair out because I can't progress the drawings as much as I want to because I've got to wait for the steelwork to get their information in. I could quite easily model that steelwork, but again, it's wasting my time long term because it's going to be overwritten by the steelworks. So just be patient as best you can and wait for the information to come, because with BIM and the contractual issues that come with BIM, if you start putting the information in and it's wrong and they're producing it as well, then there's going to be problems. So just, if you're getting it, wait for it. And finally, just a quick benefits of BIM on this project. We're obviously speed of production information. Again, just sort of 3 views, how they all interact, and one change anywhere is a change everywhere. Accuracy of the information. Again, you can take the schedule information straight out. Room scheduling and door and window scheduling on a project of this size for one person to do is suicidal almost. So just simplifying that situation, just having them produced 90% of it for you is fabulous. So, and the services you can offer to the client. You can, again, now you can produce the 3D visualizations. This was done in-house. It was done very quickly. It's straight out of Revit with a bit of Photoshop in the background. But it's something you can now offer to your client, not at the 10 grand an image expense that you would have to farm it out to somebody else for, but you can either offer it as a free gesture to get the work in the first place, because you're offering something extra, or you can offer them at a much discounted rate from what you would farm them out to. So those are the sorts of, just a quick overview of the benefits of BIM for us within the office. So thank you very much. Hopefully I know it was a quick rush through of what that project is, but I could go on for hours about it, which will bore you all. Yeah, the models of both these projects we've got on the laptop, so we can have a fly around them. If you want to have a look at exactly what's going on, please come and have a chat. And yeah, hand back to Derek now with his next presentation. Like I say, just put this back.
Better?
All right.
Yep. Okay, this is a project that was handed to us by one of our housing clients, and It was a site that happens quite often. You get a site with a planning permission, design, etc., and they just want to get on and build it. It was handed to us mainly because of the shape and the roof of the building might cause a bit of a problem. So we always seem to get problem projects from our clients. As you see, this is the planning permission, these are planning drawings, etc. And the top floor is all in the roof. So my first task was to design out the roof and look at whether the spaces, etc., had been calculated correctly. So we do that by using just roof slab spaces which occupy the rafter depths. And with that, you can then very easily find out whether you've got headroom problems. The client wanted changes to the layouts, etc. And so we were able to model out the roof very, very accurately and then replan all the, certainly the top floor to a client's requirements. We did have to check for, obviously, the escape corridors, etc. And when we went through them on the original designs, we found that we had actually one escape corridor that was 1,500 millimetres high, so that caused a bit of a problem. So we had to redesign and rejig something. There were also, was it on the original design on the top floor, no load-bearing walls either. So being a traditional, shall we say, housing developer, they don't like anything too avant-garde or anything too difficult. The engineers, we have no say on who was going to be the engineers. Obviously, with a housing client, they tell you who they've appointed, etc. I'm sure we've all been there, etc. And they were just traditional structural engineers doing stuff in AutoCAD. And they also told us who the roofing contractor was going to be as well. The outline of design was sent in DWFX to both the roofing manufacturer and the structural engineer, so that at least they had a fighting chance to see what was going on in the roof. And the preliminary floor plans were sent to the structural engineer in DWG format. The outline designs and what have you were then, we had a request from the steelwork manufacturer who was subcontracted to the roof manufacturer for DWFX format of the model, and he also requested the ACIS SAT format as well, which I believe is just text format actually, so there's no 3D information that he was sent. We eventually got the steelwork information back from the structural engineer. And then what we did was, because no one else was doing anything in 3 dimensions, we needed to check whether all these steelworks fitted within the roof and whether they worked. We actually modelled up the steelwork ourselves. Then we had the steelwork drawings back from the steelwork manufacturers. None of it was in 3D. It was all 2D CAD drawings. Again, this is one of the problems that we are encountering, is that there are companies that are at different technological levels at the moment. No one, it's very hard to find everyone doing BIM at the same level. So because of the complexity of the roof, etc., as I said, we decided that we would model all steelwork in the roof. We then checked the steelworks against our model, found some mistakes, level mistakes, etc. They were marked on the PDF, sent back to the steelwork manufacturer and the structural engineers, and they accordingly amended their DWG drawings. Everything was then signed off. The actual roof truss manufacturer actually used our drawing and our information to take off all his rafter sizes. So, he was very impressed with the DWFX and some of the sections that we did. So he actually used that for his takeoff. We finally modelled up all the steelwork and made sure it all fitted. We found we needed to raise a few of the steelworks so they would sit on some of the, or miss some of the main piece of bracing steelwork within the roof. And then when they started on site, the site manager rang, asked for all the padstone and steelwork levels, which we provided, and we didn't hear from him till he called in after Christmas. We came back from the Christmas break, 3 weeks later, we had a phone call from site. Site manager rang, and he was talking to one of my colleagues, Robert, who deals with most of the site information, and he was just asking about rainwater gutter colours. And Robert then asked the site manager, how are you getting on with the roof? We're tiling next week. And he said, oh, did you have any problems? And he said, no, this is the first roof I've built where everything fitted. We had absolutely no problems whatsoever. It went up the first time. For us, yes, it was, we had to coordinate a lot of information from various people, from all 2D information, but we were quite prepared to do it in 3D and coordinate it all. It meant a lot more work for us. But the benefits is that the client got a building that virtually went up first time with no RFIs from site whatsoever. And the site manager has made sure that the management team at Abbey Homes know about that. So that's a great benefit. It's the first time, he says this is the first time I've ever put up a roof where I've had no problems. That there is a render straight out of Revit, touched up in Photoshop. We presented that to the client, and he said, can we use it for the brochure? And we said, yeah, fine. Yeah, pay us 750 quid, you can have it. He said, done. So that is now on the front of the brochure. But again, that was straight out of the model. And so we have a young lad at work who's very into it and what have you, so we've trained him to do all this stuff and what have you. But as Bill was saying, is that accuracy is the key. This is something that is totally new for the building industry. You've got to model accurately. Everything has to be, you're virtually building. Essentially, that's what you're doing. You're virtually building, you're putting up the building in the computer and exploring all the possibilities of what you can do with the building and the structure. It's cheaper to make the change in the computer than it is out on site. So this is why you have to streamline your working process within your own practice. If you can't collaborate in your own practice and get things accurately done, then that's something you must train for within your own work groups. It is something that we stress very strongly in our practice. We try to get it right once, and and it saves a lot of time if you can do that. And that's the end of my presentation as well. Okay.
Perhaps we can, whoops.
It's all that water you're drinking,
Yeah,
isn't it?
exactly.
I think it's a really good opportunity to ask some questions, and while you're thinking about it, I'm going to use my prerogative to ask a question myself. Bill, you mentioned culture change and some of the challenges. I gathered that certainly one colleague was very resistant,
Yes.
but you also said you've got everybody more or less on board now. And I thought it'd be quite useful to hear your perspective on how do you change cultures when there is perhaps some degree of resistance. I'd be interested to know. So I'm going to use that as a first question.
Okay, there was huge resistance. He was an ArchiCAD user to begin with, a fierce competitor, obviously, of Revit. So he was using that for many, many years whilst we were still using AutoCAD, and he did all his planning drawings. That's all he does primarily is the planning side of things, hands it over to us. So the fact that he used ArchiCAD and we used AutoCAD, we tend to bin all of his stuff anyway because it wasn't really compatible in a nice way with AutoCAD. When Revit came in, we basically just didn't renew his ArchiCAD contract and gave him Revit and said go. And that was it. There was lots of grumbling and moaning. There was lots of resistance to the accuracy that we require at the end that he wasn't putting in at the beginning. So when we got busy, I think we gave him a lot of work and drawing work to do, and then he started realising what he needed to do and why things weren't working and why it was so difficult for him to do it. And we said, well, because you drew it. You didn't do it properly, and now you've got to do it again. So it's persistence, basically, is the long and short of it is persistence, and keep educating them on what they're doing wrong.
Also, being a small office, you know, you can take the piss out of them as well. So that usually tends to make people take notice of what they're doing, etc. And you know, it's in a large organisation, it must be a nightmare, to be quite honest. I would have thought.
I think that's the thing, in a way, the SMEs have got quite a good opportunity where they are, because essentially we bought it a while ago, but probably about 2.5, 3 years ago, we just said everyone's going to be using it. So we bought a license for everyone, so it wasn't different people using different softwares. So if you're in a small organisation, essentially, the directors could say, look, we're going to implement it, and we're going to embrace it. Obviously, when we first started, there were issues where we had to flip back just because of our capability or knowledge of how to use it. But if you do persist, then it obviously gets better. And now there's people in the office who've never used 2D drawing before, so they came out of diploma and have never used CAD in the 2D conventional sense. And then they would go back and they keep moaning that they're having to deal with 2D drawing. So I think at a certain point it flips. But with a small practice, you got much better chance, because obviously with the bigger contractors or architects, they're having to go through directors and board meetings and writing new manuals, etc. We essentially just said everyone's going to use it.
It is down to change of philosophy of the office. You know, you've got to have people who look at the benefits of having. Traditionally, what you would do is you sketch out your planning drawings and concept drawings, then you'd do a more involved drawing, and then it would go to technical, and then you make some more changes. Planners would do that. With the BIM thing, is the whole model goes from the data has an extended life cycle. It goes from concept all the way through to sales, and then on towards facilities management. So as soon as you get into detailed design, you've got to start thinking about what these spaces are or how they're going to be occupied accurately. Then it saves work down the line when you come to do your technical work and sales.
Okay, thank you for that. Do we have some other questions?
I teach CAD, Revit, BIM at a low level, you know, to try and get students familiar. You mentioned that you had skills and certain people in the office have particular interest. You're talking about Photoshop and renderings. I'm interested in knowing what our guys to know when we walk into interview. That's the main thing I try and get a handle on. I've talked to the large industry, but the opportunity out for the SME. What
for us, if they've got a focus, then great, if we've got a need for that focus. But if they want, I suppose that the widest breadth of obtaining the job from a BIM perspective is just having a general overview and having working practices that we require using BIM. If they come in and, I know it's not really the architectural way at uni to sort of hone them down too much because you want them to be creative, but you can still do that and still have the accuracy or know what you're doing when you're being more fluid with your designs. There's concept modelers within the programs which allow you to just, sort of like you would in Rhino or 3D Studio, just sort of pull and push and make objects. But you just need that ethos of what BIM is and how it progresses. What program they use and what platform they're on is irrelevant largely because a practice will have that platform. So I'm no reseller of Revit, for example, but they are largely, because they're all the Autodesk, they're probably going to become the industry standard largely, or be the most widely used. So that would probably be the one to aim them at, but it's whatever they want to use. But it's that ethos of what BIM is. It's not a program, it's an ethos. It's a way of life almost, or a way of working.
It's the thought process as well that goes behind putting together a building needs. I mean, so one of the interesting things that we do at the office is, I don't know whether anybody else does it in their practice, but how well do you know that the person sitting next to you, how well do you know that they can think in 3 dimensions? What exercises have you done within your practice to know that your employee can think in 3 dimensions, can actually physically take a 2D drawing and put it together in his head? How many practices or how many construction companies and whatever actually do that test? I don't know whether anybody does it at university. I don't know whether, because we all naturally think that we go into this industry thinking, oh yes, we can think in 3 dimensions, etc. But how many people do you actually know that can do that? So it might be something that you might want to look at university, because everybody has different abilities to be able to think in 3 dimensions and what have you. But it is an essential thing. But the thing is that we're now entering. We've got programs now that can do 3D information and what have you. But you still need to know the process behind it. You still need to know whether it's instinctively right or wrong what you've drawn. I always take the analogy of how many remember calculators coming in. And what have you, and we're doing all our string calculations on hand drawings, calculating them out and what have you. And I used to stand over the backs of my trainees and say, that dimension's wrong. And he said, I did it with a calculator. And he says, well, as you've got 7 dimensions all ending in an odd number, and your overall dimension ends in an even number. So something's wrong. So it's the process of 3D thinking and how to put it together that is important. And we find that even when we get people from, and we hire people from, shall we say, the employment pool, their varying skills of their abilities to be able to think in 3 dimensions is, for our office, is not what we require. I don't know whether...
Yeah, I think we've had work experience people who are like 16, 14, who in about a week can produce pretty good models in Revit. It's not, the software is becoming more and more easy. I don't think, like I said, it's not the issue. It's more about going back to basics of having the kind of tenacity to be able to kind of work things through, understanding real life. I guess there's a kind of a usual debate between university and practice. Things like cost and fees and all those things, which are completely lacking. I mean, I did my degrees in London and none of that. I just kind of learned Photoshop really in a couple of programs. It would no relationship back to things. So there's a bigger debate about education stuff. I think with the software, everyone is able to pick it up very quickly. I mean, that's one of the reasons that the software sellers are doing it, so they're going to make it as easy as possible to ensure that as many people adopt it. So I don't think learning software is necessarily the issue. I think that's pretty fundamentally easy. And that we've shown that in the office from work experience too.
Yeah, we have as well, yeah.
It's the cultural change, isn't it?
Yeah, that's interesting, I think. Yeah, I think, as you say, it's the culture, it's the ethos, it's the perhaps learning how to collaborate effectively and perhaps being able to take what might seem to be criticism,
Exactly.
because I think that's quite hard for some people. I think you were next, actually. You had your hand up, didn't you?
Yeah, I just had a question for Daz. Really.
Yeah.
In your presentation, you touched on skylight sunlight modelling,
Yeah.
and you say you use farm out to the consultant.
Yeah.
I'm just wondering if the consultants that you work with on that aspect, how do they integrate with BIM? Because, you know, from my perspective, we do that. We do sunlight daylight
Yes.
analysis. We don't use BIM, we don't use Revit.
Yeah.
So I'm interested to know how
Well,
those types of consultants feed into the process.
I work close with one in London, and they're a small kind of outfit as well. We've kind of agreed recently that, well, also we got the BIM data these days and the 3D kind of aerial photographs. There's still an initial kind of discussion about what it is. We can either then produce, obviously, our proposals, like I think we showed in the beginning, because we can buy the context in 3D as well. We can kind of actually say, look, we're looking, as architects, we want to try and mass up here because of certain design reasons or whatever the concept that we might have. We then give it to them, they give the model to them, so that they're not starting with a scratch, but you can obviously spend the time surveying the windows, etc., around our site. But we've already given you what we're looking to get in terms of shape, so there's not having to reinterpret our sections or our models. It's really about kind of speeding up the workflow that we saw anyway. So, you know, we give you the model, we can potentially give you the site as well, but actually it's a site windows and things that you need to kind of obviously model more accurately. We'll give you 3 or 4 options of what we want to have on the site, and then you can run the analysis and cutbacks, etc. So it's just having an understanding and a dialogue with that, so we can provide you more accurate information and get back to the whole accuracy thing. And running daylight or just the sunlight diagrams, we should be able to make kind of more informed decisions, so that we're not surprised somehow when you guys come back and say, actually, look, that's just not going to work. Or so there's just a bit of kind of quickening up the process, and I guess that's good for clients. Essentially, it's going to be good for the client, and the client's happy, then obviously they'll keep coming back to the kind of group who's delivered that. So
but you're right, from our perspective, we do, you know, fee is adjusted if we're provided with a 3D model.
yeah,
Obviously, if we have to build one from scratch ourselves,
yeah,
then that's will work for us. But if guys like you coming along with Revit models, that's brilliant.
yeah. It's what we did in the hotel scheme. We just didn't have that much time, so we just gave that hotel scheme to them, and they ran with that, basically.
And I know there are Revit plugins available now which do daylight factor calculations.
Yeah.
So do you use that?
There's some things in there, but I think the point of kind of the sign-off, essentially, or the report from the M&E, daylight, there are certain things which still need to be done, I guess, by a specific profession. I don't think we're trying to like take it all on board as such, but there are tools out there. Just essentially, it's about making more informed design decisions as you go through the kind of different stages. So if it's from the beginning, just looking at a mass, I think that you showed, and looking at the effect of like the electric pylons, for example, to adding more and more data, analysing that more accurately, so that as a team, you're making more informed decisions. Again, just kind of quickening up the pace. Just trying to have everyone inputting at the beginning would be ideal, so that it's all resolved as you go down. So you're not wasting time, you're not sort of duplicating work. That's where I see the benefit of that, really, to be honest. So working in partnership more than anything else. And if you guys have any...
Okay,
Yeah.
any questions? Steve?
Yeah, I sit on some British Standards Institute committees, and mainly to do what is access, but I've also advised facilities management standards. And I'm quite interested in the relationship between design and operation, and design for operability. And a lot is made of BIM in terms of its benefit facilities management, but in terms of how we design, how do you see that affecting things? And before if I might also say that there's a conference coming up on the 26th of April. If there's anybody here would like to come to a Smart Cities conference in Bristol, I've got a space going, so for which there is a transferability of questions between BIM and Smart Cities, in my view. But going to the question about...
To an answer, or shall I? Or?
You can, yeah.
In terms of, if I understood correct, the question is obviously about how do you bridge that gap, I guess. I think with the things like the BS standards which have come out, the BS 1192,
yeah.
and then there's this PAS 1192 Part 2, and 3 is going to be FM related. I think the key thing that's coming out is the fact that getting the operator to be involved in the design stage early. It goes back to the idea of knowing what you want the model to do or how useful it's going to be at different stages and who it's going to be used by. During the design stage, you'll have like the project sort of design model, the model information model, and that's really to kind of coordinate the construction, etc. When you then hand it over to the contractor, certain information might be added or taken away. And then, but at the same, all the way through, you need to know what, for example, yourself or the people who are going to be using it, they might not need to know what's underneath this floor, but they might need to know what the lighting is. So there's no need to model all the ones below it, for example, but you do need to show the right lights, for example, in the right place. No. Just, if you're going to, in that discussion, it's the idea of, again, just knowing what the end goal is and then designing or modeling. In terms of interfacing, I mean, we've looked at some software where it's not really to do with Revit, ArchiCAD, Bentley, or whatever it may be. You're able to essentially tag. I think the Manchester City Council is probably the kind of most, the real project that's being used, and we had a presentation the other day. You know, that they've seen the benefits from planning stage, sort of English heritage and listed building status, but all the way through to archiving the design process to now actually kind of being able to monitor. And they found great uses, like they can now use a model as a guided tour, for example. They can use the thing for the fire in the fire service, for example, so they can, while they're visiting the site, they can map out this building, know what's happening.
Yeah.
Or guide to DVA users, for example, how to get around the building. So they're finding lots of different uses and different ways of using it. And I think as you use it, you find different ways of presenting, whether like the staircase, we can just show a little bit of model of things. So as people use it, they're finding different ways of doing it. But I think coming back to you, it's just purely about understanding, again, the clients and the users and the model being enriched or de-riched.
Quite a lot of clients don't actually realise what's happening, so and what can be done.
I think that has a big benefit, is effectively it's involving them more in the
yes,
process,
yes.
so that what they get at the end is not a surprise, and they can also inform it.
That's exactly what those documents are about, the BS and the PAS, and the full life cycle and demolition.
Yeah. And presumably clients, when they can see what they can have, they're going to be having raised expectations as well, you know, so it's sort of
You've got to manage that.
More difficult to achieve that if you're not on this particular bandwagon, you know.
Yeah, and it's about managing it, isn't it? So if there's additional service, you can charge them additional service. You know, if they keep going back to do things, and that's for an architect as a whole.
Yeah. Do we have some more questions? Do you want to put your back there?
Just a quick one. How well do you, like, in practice, like, how well working together on one project? Do you get any errors and stuff? I was just wondering.
It's brilliant, quite frankly. Going from the days of AutoCAD 2D, somebody's drawing a section, somebody's drawing a section somewhere else, and there's no sharing of information there whatsoever. On smaller projects, for instance, an individual house, unless you're throwing in tons of detail, there's probably no need to be collaborative in terms of more than one person working.
But we do work share everything, just in case.
There's functions within the programme, but something like Ferrari, which unfortunately we didn't really have anybody else working on it, but something that big, you can, when you select something, essentially, you take control of that element so that people cannot interact with something that you've got control of. And then when you do your saves, which are sort of every 15 minutes, or like in our office, once or twice a day, you relinquish control of those things so that then other people can pick them up. So there's absolutely, I say this almost 100%, but there's absolutely no way that you can get errors. And if you do, if somebody puts a wall in, because everything's got, going back to the database issue, or how it is underneath, it's just a database. So if I put a door in, it's given a code which is sat in that database that you never see. But if somebody puts in a door completely somewhere else, it might have the same code because they're working within the same project, but won't go into the ins and outs. But essentially, when you then collaborate that back to the central model, because you work in satellites files, so when you send that back, if there is a clash with the database, it just tells you there's a clash, we've renamed one of the doors for you. So you cannot do it. If you delete the door and somebody tries to then move it because they think, oh, I want that door somewhere else, it will say somebody else has got the door and they've already deleted it, so you can't have it. Start again. So, yeah, collaboration is brilliant, and it's 99.999% error-free. So
you have, like, do you have a server of the file? Is it
Yeah, you don't have to.
Or was it you take the actual file off and show
Yeah, you do. You have the central.
You save it and send it back.
Sort of. You have the central file which sits on a server or a shared place somewhere, whether that's cloud or in your office. You then save a copy of that, but that copy is intrinsically linked to the central file, what they call it. So every time you select a wall or you take control of something, it sends a message back to the central file. It says, right, Joe Bloggs has got control of that wall, tell everybody else that they can't have it. So it's that sort of idea. When you then do what they call a sync, well, it's not a save anymore, it's synchronized with central is what they call it. So you then click save essentially, and it synchronizes all of the changes up to the central file and downloads all the changes from other people to your local file. So that's the sort of basics of it.
There's a workshare monitor that you have up, and then whenever someone syncs to the file, and if you're working on it, you'll get a notification that the drawing's been updated. So therefore, it'd be advisable for you to sync as well, so you know what the updates are. So
I think, I mean, in our office, we just sort of sit in a long line, and you just shout.
Yeah, that's it. Yeah.
Say, look, you know, what are you doing with my model, for example? So I think, there is obviously these elements within the software which allows you to work. You've got multiple floors, for example, or you're working on different sites or practicing different areas. But I know we found we just shout basically across. There's no sort of sending messages and stuff, and it kind of pops out. So I'd imagine in a similar, if you're working in these kind of small practices, there is that ability just to directly communicate. It doesn't have to go through these sort of change orders and whatever.
That's
so
right. Yeah.
There's a kind of a dumb way to do it, and sort of
the
proper way to do it as well. Exactly. Yeah.
There is the functionality to do it.
Exactly.
Exactly.
But at least you get the collaboration within your own workspace then by doing that. It's hugely efficient as well, because you can do things very quickly. So if someone says, look, I'm in trouble here, guys, I've got to meet a deadline, everyone then can pile in and help out. We've had several projects like that where, you know, the client's come back and says, could I have something by the end of the week? So everyone's piled in, got the work out of the way. And you could never do that with normal 2D AutoCAD or any 2D package. Yeah, so it's tremendously powerful, and it makes you more efficient.
Yeah, out of interest, being provided with Revit and BIM, do you think from your own personal point of view, would that encourage architects to make more sustainable and efficient designs? Because you can assess the life cycle and what inputs you have in the material.
Yeah, definitely, because the idea is to be able to, if you're virtually building something, just from a pure materials point of view, the idea of you can have, for example, off-site construction, which you know, because everything is coordinated, you can be much more certain, for example, of off-site construction. You can bring in, for example, kit made in a factory, speeding up the process, which is sort of probably what happened in the Ferrari as well. So it allows you to kind of reduce the wastage on site, because if everyone's on board, then they know exactly how much to order, for example. So there's that element of it. And then there's obviously the kind of environmental, like being able to assess the building, running things like the energy analysis kind of early on. You can make the big changes, which will help in the kind of down the line, for example. Then there's something people say, 80% of the end cost of the building is in the first 20% of design. So if you're just kind of drawing on sketches, that's going to be lost, and that you're going to have issues down the line. Whereas if you're collaborating and you're being able to get all the accurate information early in that 20%, you're able to make much bigger savings down the line. So it's definitely to do with that, partially off-site, reducing waste on site, and actually with the sequencing, for example, the construction contractors can sequence things much more accurately as well. So they're able to get less kind of deliveries of concrete or more kind of speeding up the process on site as well. So there's multitude of ways which it can reduce in obviously kind of making a green and leaner kind of building. That lean construction, I guess, element of it. So definitely.
Any more questions?
I just had a quick question about liability. It slightly worried me when you said you were drawing the steels and putting them into the building into your model and how those are used. We found that when it gets to the contractor-led projects and you get down to the M&E subcontract and they don't have a BIM, they're not BIM enabled, and suddenly the model you had from the consultants